Okay, so now we're going to look at solving a system of linear equations using some algebraic methods. So the first one we're going to look at here is substitution, and then we're also going to look at elimination. The last video I did was about solving it graphically. Sometimes that's not convenient if we end up with decimals. I think in both these situations we end up with whole numbers, but it kind of just depends on your preference a little bit there. So to use substitution to solve an equation, first, what do we know that y equals? If we look at these two equations, we have 5x plus 4y equals 23, and we have y equals 2x minus 4. So I already know that y equals 2x minus 4. They told me that right here. So can we use 2x minus 4 instead of y? Yes, that is called substitution. So I can substitute one value for another value that I know to be equal to it. So in the equation here, 5x plus 4y equals 23, instead of y, I'm substituting 2x minus 4. So hopefully you can see that with the color changes. The blue is the original equation and y is in red here. So that's what I substituted. All right, so I'm going to distribute this 4. So I have 5x come down, and then 4 times 2x is 8x, and then 4 times 4, negative 4, is negative 16, and then equals 23 also comes down. So now I'm going to combine some like terms. I have 5x plus 8x, so that gives me 13x, minus 16 equals 23. Those didn't change. Now I can start solving for x. So I'm going to take what's being added and subtracted on the same side as the variable, and I'm going to move this over. I'm going to undo this action. So I'm going to add 16 to both sides. 13x is going to drop down here. 16 minus 16 cancels. 23 plus 16 is 39. And then to undo the multiplication, I'm going to divide both sides by 13. So 13 divided by 13 is 1. So that's why we just have x. We don't have to put the 1 in front. And that equals 3, because 39 divided by 13 equals 3. So we can see we have x. So now plug in x equals 3 to either of the two equations to solve for y. So it doesn't matter which equation I choose. I'm going to choose one and plug it in. But I'm giving you a hint. Y equals 2x minus 4 is already solved for y. That's an easier one to use. So that's the one I'm going to use. So y equals 2x minus 4. So now we can see I left x in blue. The rest of the equation is in red. So I'm going to take this 3 and I'm going to plug it in here. So it's going to be 3 times 2, which gives me 6, minus 4, which gives me 2. So now I have my coordinate where those 2 points, or where those 2 lines would cross. You can solve this graphically as well. This one definitely would be easy because it crosses on a very specific point. There's no decimal places involved, so it would be very simple to see that as well. All right, so if we look at the next method, this is called elimination. So this is when substitution isn't easily set up for us. So if you remember, this one was easily set up. I already had y equals. That's very, very easy for me to just take this amount and plug it in for y. Well, if we look at these equations, they're not set up as nicely. There isn't just one that I know what x equals, I know what y equals. I'd have to do some manipulation there to get that to equal x or y. So another method for solving the system of equations is to use elimination. So instead of solving for one variable, we are going to stack them as if we would in like any number plus another number. So like in a regular addition subtraction type situation, we're stacking them. Make sure that they're lined up so the x coordinate or the x pieces are above each other. Terms. I need to use the right vocabulary here. The x terms are above each other, the y terms are above each other, and the constants are above each other, or in line with each other. So you definitely want to make sure. Now this one is kind of an introduction to elimination, so it is already set up nicely for us to eliminate. In order to eliminate something, I want to subtract so that when I subtract straight down in the columns, something disappears, it eliminates itself. So if you think about 4x minus 4x, what's going to happen with those? They're going to eliminate. 4x minus 4x is 0. So this is already set up nicely for me because that was already the equation how it was given. It's not always given that way. Sometimes we're going to have to manipulate it a little bit by changing those numbers, but I think that's something that we'll do as we move forward a little bit. We're not worried about that quite yet. So now I have 5y minus 3y. Make sure you're subtracting. So you get 2y. Negative 4 minus 16, sorry, minus 12 gives us negative 16. So it's a negative 4 and then minus 12. So I was already at negative 4 and I'm going 12 more negative from there. So that's why it's negative 16. So be careful about adding and subtracting integers. And then to get y by itself, I just simply need to divide both sides by 2. And I get y equals negative 8. So now, just like I did in the last one, I'm going to take this negative 8 for y and I'm going to plug it in to either one of those two equations. Really, neither one is easier than the other because neither one is already set up to be equal to x or be equal to y. So we just pick one. I'm pretty sure, yep, I picked that first one. So I have 4x plus 5y equals negative 4. So I made it red just to make it clear. I'm changing y into negative x. I'm substituting it. So even though we're using elimination, we're also using substitution. So 4x plus negative 40, because 5 times negative 8 is negative 40, equals negative 4. I'm going to add that 40 to both sides because I want to start to get that x by itself. So I have 4x, the 40's cancel. Negative 40 plus 4 gives me positive 36. And then I'm going to simply divide both sides by 4 to get x all by itself here. So x equals 9. All right, so this would be the point at which those two lines cross. And you can definitely use graphing calculators in class or online because sometimes seeing that visual of the graph can also help you see where those 2 points are, or those two lines are crossing. All right, so this was using substitution and elimination to solve a system of equations. I hope that helped, and I'll see you in the next video.